Okay, so let's look at question 6 from exercise 4C.3 of our text. So the first part of the question asks you to find vertical asymptotes, and for this rational function, well, think about this. If you have a number, say 4, you divide by 0, you go to calculator, you see mathematical error, and in fact mathematically this is undefined. Sometimes we call it infinity. Okay, well, u to infinity. So if the denominator is 0, that expression will be undefined, and this would cause the rational function like this to have vertical asymptotes. It could be 1, it could be 2, it doesn't matter, but in this case, so we just let this be 0, the denominator, and try solve it. Solve this. Okay, so we have x equals 2, 3. So therefore, the vertical asymptotes are this. These are the two lines. There are two vertical lines, and x equals 3. Now to find stationary points, we would have to, of course, make a partition to find f prime. This is a quotient, so we would use a quotient rule. Now this is the u is, if you notice, the u is actually x squared plus x minus x, and the v is this, the quadratic expression. So the formula says that here we have v du dx, which is 2x minus 1, and minus u dv dx, so that will be 2x minus 1. Okay, so if you simplify this, you would get something like this. If you simplify, I skip ahead, you make sure you check work properly. And so we set this be 0, f prime be 0. We want to find stationary point, so of course we set f prime be 0, and as you can see, the denominator can't be 0, so it must be this, the numerator. Is equal to 0 means that x equals to half. So so here we have it, a stationary point. Calculate the corresponding y. So this is a 1 over 25. So you know how to do this, right? You sub this x value back into the function, and you get 1 over 25. And you must test with a sign diagram. Now, the nature of the stationary point is very important. So half, and you test with sign diagram using the f prime right here, which is this one. So you probably choose x equals to 0, to the left of half, and you might find that this is equivalent to positive, and then this is equivalent to negative. But that's not enough, right? Because you notice that there are two vertical asymptotes, the critical values. They are part of the critical values, so you have 3 critical values, 1, 2, and 3. So you need to extend your sign diagram and include -2 and include 3, and find the sign, complete the sign diagram right here, plus, and choose a value, choose say 4, and you probably get some value, doesn't matter, but we know it's going to be negative. And from there, kind of shape of the graph is always positive, like that. This would always be positive, and then negative, when it cuts through half. And this is what you get. Oh, I made a mistake here. It shouldn't cross the -2. Yeah. So, and finally we can conclude also that there is a local minimum at the point half and 1/25. We're not asked to sketch the function, but so we'll stop here for the moment.